Function 6, graph of inverse functions. Given the graph of y is equal to f of x, we can sketch the graph of f inverse of x by reflecting y is equal to f of x in the line y is equal to x. All right, so all that this is saying is that if we have the graph of a function, we could obtain the graph of the inverse function by reflecting the graph of the function in the line y is equal to x. One, whenever you reflect a point in the line y is equal to x, the x and y coordinates interchange. Whenever you reflect a point in the line y is equal to x, the x and y coordinates interchange. So x becomes y and y becomes x. Two, the line y is equal to x is a straight line that passes through all points on the graph where x and y have the same value. The line y is equal to x is a straight line that passes through all points on the graph where x and y have the same value. All right, let's have a little illustration. So here in this diagram, we have the line y is equal to x, and we have the graph of a function. And what we want to do is that we want to obtain the graph of the inverse function. And all that we're saying here is that if we reflect the graph of the function in the line y is equal to x, we will obtain the inverse function. One of the simplest ways to do this is to determine some points on the function and then determine what would be the corresponding point on the inverse function, using the fact that whenever you reflect a point in the line y is equal to x, the x and y coordinates interchange. So for argument's sake, let us say a point here. That point is could be the point 1, 2, 3, 4. Let's say 4, 1.5. Now, if I reflect 4, 1.5 in the line y is equal to x, it's going to become 1.54. So 1.5 would be between 1 and 2, and that corresponds to 4. 1, 2, 3, 4. So that would be the corresponding point. All right. Here we have the point 2, 0. Now, if we reflect the point 2, 0 in the line y is equal to x, we're going to get the point 0, 2. So the point 0, 2 would be here. This would be the corresponding point on the image. Let's put in one more. Let us say here. This is approximately, let's say, a half minus 3. A half minus 3 is going to become minus 3 a half. So it's minus 3, 1, 2, 3, minus 3 a half. I'll put that point about here. So now that we have a sufficient amount of point, we can draw the graph of the of f inverse. All right, so it's a curve. So this has to be done by freehand. So if this is the function y is equal to x, the function we just drew would be y is equal to f inverse of x. So we can obtain the graph of f inverse, the inverse of a function, from the graph of the function by reflecting the graph of the function in the line y is equal to x. Now, the line y is equal to x is a straight line that passes through all points on the graph where x and y have the same value. And whenever we reflect a point in the line y is equal to x, the x and y coordinates interchange. All right, example 21. Example 21 says sketch the graph of f of x is equal to 2x plus 1 and hence sketch f inverse of x. All right. So if you're going to sketch a graph, first of all, f, f of x is equal to 2x plus 1 is a linear function. And the graph of a linear function is a straight line. Additionally, we only need 2 points on a straight line graph in order to draw a straight line graph. So let us see if we can obtain 2 points. We have y is equal to 2x plus 1. I could say when x is equal to, let's say, when x is equal to, let us say, minus 1, y would be 2 times minus 1 plus 1. 2 times minus 1 is minus 2. Minus 2 plus 1 is minus 1. So y would be minus 1. So that would be 1 point where x is minus 1 and y is also minus 1. We could also maybe use when x is 2. When x is 2, we would obtain y is equal to 2 times 2 plus 1, which would be 5. So this would be the point 2, 5. So we have 2 points on the graph um, of f of x is equal to 2x plus 1. The 2 points would be minus 1, which would be here. The next point would be 2, 5, which would be here. All right, and of course, the y-intercept is 1. All right. So in y is equal to 2x plus 1, 2 would be the gradient, and 1 would be the y-intercept. That's the value, the number where the graph cuts the y-axis. All right, so once I have my 3 points, I could what? Draw a straight line through them. All right, so it's a sketch. I didn't use a ruler. If you wanted to, I guess you could use a ruler with your sketch. We need to draw the line. Also need to draw the line y is equal to x. Now remember, the line y is equal to x is a straight line that passes through all points on the graph where x and y have the same value. So it passes through the point 1, 1, 2, 2, 3, 3, 4, 4, etc. Obviously, it would also pass through the origin. So let's draw a sketch of this graph. This is the line y is equal to x. So we have the graph of f of x, and we have the line y is equal to x. Now let us reflect. Remember, if you reflect a point in the line y is equal to x, the x and y coordinates interchange. So the point we have here, which is the y-intercept, which is 0, 1, 0, 1 would become 1, 0. So 0, 1 is on the function, and 1, 0 would be the corresponding point on the image. So that would be here. All right. Another way we can look at it is that whenever you reflect, a point in a line, the the object and the image, corresponding points on the object and the image, are the same perpendicular distance from the mirror line. The mirror line is y is equal to x. In this instance, we will evaluate this distance diagonally. So this is 1.5. The image would be the same distance, but on the other side, a half, and then 1 diagonal. This would be the image. All right, that's another way we could look at it. We could also test it. Um, Remember, whenever you interchange, so this distance here, sorry, and this distance here would be same, and that line would meet the mirror line at right angles. So both the object and the image would be the same perpendicular distance from the mirror line. When you're reflecting in the line y is equal to x, and the scales are the same on what both axes, you can evaluate that distance diagonally. What else? So we can also test it to see if it's true. The point we just reflected is the point 2, 5. Now, if we reflect 2, 5 in the line y is equal to x, it should become 5, 2. All right, and as we can see here that this point is 5, 2, so it is correct. So now I have sufficient points on the image to draw a sketch. All right, so this is the graph of y is equal to f of x, and this would be the graph of y is equal to f inverse of x. All right. So here we're illustrating that in order to reflect, um, in order to, we can obtain the graph of the inverse of a function from the graph of the function by reflecting the graph of the function in the line y is equal to x. All right, example 22. It says if y is equal to 2x squared plus 3x minus 1, identify the domain and range of y. Does the inverse of y exist? All right, first of all, y is a polynomial. And essentially, that means that y is some expression in x where the terms are separated by plus or minus signs. The powers of x are not negative and they're not fractions. So y is a polynomial. Now, for all polynomial, the domain is the set of real numbers. So the first thing, a the domain of y is x is an element of the set of real numbers. To determine the range, we would need to determine at least what is the minimum turning point. All right, to determine the minimum turning point, the minimum turning point is minus hk, and this minus hk is from our knowledge of completing the square. All right, where h h is equal to b over 2a and k is equal to 4ac minus b squared over 4a. So what we would have is h is equal to b. So a is 2, b is 3, and c is minus 1. So it would be b, which is what, 3 over 2a, which is 2 times 2. So h is 3/4. K would be equal to 4 times a, which is 2, times c, which is minus 1, minus b squared, which is minus 3 square, all over 4a, which is 4 times 2. K is therefore equal to minus 8 minus 9 over 8. So K would be equal to minus 17 over 8. And the turning point, which is minus HK, so minus HK would be minus 3/4, because H is 3/4. K, which is minus 17 over what, 8, would be would be the minimum turning point. All right, so the minimum turning point essentially means that the graph does not fall below this point. All right, so if we wanted to, we basically could do a sketch of this graph to illustrate that point. Just a basic sketch, is nothing big. Y, X. First of all, the function I think is Y is equal to 2x squared plus 3x minus 1. Minus 1 at the end is the y-intercept. So that's minus 1. Um, let us say that this is also minus 1 on the x-axis. And that the minimum turning point is, let's say, minus 3/4. So x is minus 3/4. Y is minus 17 over 8, which is minus 2 and 1/8. So let us say this is, say, roughly here. All right, from this information, I can do a rough sketch. My graph could possibly look something like this. All right, we didn't get everything perfect, but we'll get the gist of it. All right, let's maybe do that sketch again. All right, so this is a sketch of a function. Notice that at the bottom here is where we have y is equal to minus 17 over 8. That's a minimum point. Now, the graph does not fall below this point. Therefore, any value of y below this point cannot be in the what range, is not in the range. It's a part of the domain, but it's not a part of the range. Therefore, B, the range y is greater than or equal to minus 17 over 8 is the range. All right, and the basic point is because the graph does not fall below this point. If the graph does not fall below this point, every point, first of all, there's no point on the graph below this point, below this line. So any point below this line is not a part of the graph, therefore is not a part of the range. Only points which are on the graph, only y values which correspond to point on the graph are a point of the range. All right, I think we're asked one final question. Does the inverse of y exist? No, the inverse of y will only exist if the function is bijective. For it to be bijective, the function would have to be both injective and surjective. Just by looking at it, I can see clearly that it's not injective. Because if I draw a horizontal line through the graph, for the function to be injective, it would have to cut the graph only once, or at most once, for it to be injective. So it cuts it what? The horizontal line cuts the graph what? 2 times. Therefore, it is what? Not injective. If it's not injective, it does not have an inverse. All right. We could also show that it's also not surjective. Well, that's just showing that it's not injective. But if you draw a horizontal line below y is equal to minus 17 over 8, you can see also that it's not surjective, because there are values of y in the domain which do not correspond, which do not have a corresponding value of x in the domain. Therefore, it is not surjective. If it's not surjective and it's not injective, therefore it is not bijective. If it's not bijective, it does not have an inverse. So C, I could say y is equal to 2x squared plus 3x minus 1 does not have an inverse. All right, next example. Example 23, a function f is defined by f of x is equal to x squared minus 2x plus 3, um, where x are the domain elements, are elements of the set of real numbers, and the x is greater than 1. Write f in the form a into x plus b squared all square plus c, and hence find range of f, the inverse of f, the domain and range of f inverse. All right, let's start. So first they're asking us to complete the square. We must arrange x squared minus 2x plus 3 in the form a into x plus h square plus k. All right. I changed up the numbers a bit to make it in keeping with our formula. Now, the formula here from completing the square is h is equal to b over 2a. So h would be minus 2 over 2 times a, 2 times 1. So this is minus 2 over 2. H is minus 1. All right. Let's get k. K is equal to 4ac minus b squared over 4a, which would make it 4 times a, which is 1, times c, which is 3, minus b squared, which is minus 2 square, all over 4 times 1. So this is going to be 12 minus 4 all over 4. So that is 8 over 4. K is 8 over 4, which is just 2. All right, so therefore, x squared minus 2x plus 3 would be equal to a, which is 1, into x plus h, which is minus 1 square, plus k, which is 2. So that's the first thing we're asked to do. All right, what else were we asked to do? We're asked to hence find a, the range. All right, the range. Remember that minus hk, which is minus which is minus 1 minus h k, which is 2, which is the point 1 2, is the minimum turning point. All right, so if that point is the minimum turning point, it means therefore that the range, the domain, will already have the domain that a, the range a, the range a the range of f is y is greater than or equal to 2. Remember, 1 2 is the minimum turning point. So no part of the graph falls below y is equal to 2. So only values of y 2 and above are in the range of the function. B, the inverse of the function. Remember, we just arrange f of x is equal to x minus 1 square plus 2. One more thing about it, we were told hence. So hence means that whatever you just did, what were you asked to do first must be using what you're going to do next. So let's carry through the 4 steps. We have y is equal to x minus 1 square plus 2. So that's step 1. All right, and essentially in step 1, all we're doing is all we're doing in step 1 is to write the defining equation, which is to take out f of x and put y. Step 2, we have to interchange x and y. So x is equal to y minus 1 square plus 2. When we interchange x and y, essentially all that we do is wherever x is, we put y, wherever y is, we put x. Step 3, we need to make y the subject. So I need to isolate y, I need y by itself. First of all, let's carry over the 2. So I have x minus 2 is equal to y minus 1 squared. If I find the square root of both sides, I'm going to have the square root of x minus 2 is equal to y minus 1. Then I'm going to take over minus 1. I'm going to have y is equal to minus 1 comes over as plus 1. Well, here should be plus or minus the square root of x minus 2. So that's step 3, to make y the subject of the formula. Step 4, take out y and say f inverse x is equal to 1 plus or minus the square root of x minus 2. Lastly, we're asked to determine the domain and range of f inverse. All right. Remember the relationship between a function and its inverse. The domain and range what interchange. So since the domain of f was y is greater than, sorry, since the domain of f, sorry, since the range of f was y is greater than or equal to 2, that would become the domain of f inverse. So x is greater than or equal to 2 is the domain of f inverse. All right, and again, the basic reason for that is this. All right, um, the relationship between a function and its inverse is that the domain and range elements interchange. So whatever is the range for the function, that becomes the domain for the inverse. So the range for the function was y is greater than or equal to 2. So that becomes now the domain of the inverse, which is x is greater than or equal to 2. All right. The domain for the function was x is greater than 1. So that becomes x is greater than 1, y is greater than 1 becomes y is greater than or equal to 1 is the range of f inverse. All right. Again, the relationship between a function and its inverse is that the domain and range interchange. All right, the last question. In the last question, we're told that the function of f is defined by f of x is equal to x squared minus 12x plus 13, where x, the domain, are the set of real numbers, but x must be greater than 3 over 2. We're asked to sketch the graph of f of x and hence sketch f inverse x. All right, if we're going to sketch f of x, we need to complete the square so that we can determine what is the minimum point. All right, so the minimum point is minus hk. So h is equal to b over 2a. b over 2a would be minus 12 over 2 times 4 minus 12 over 8. So this is minus 3 over 2. All right, so this is h. So minus h would be minus 3 over 2, which is 3 over 2. All right, let's determine what k is. Now, so minus h would be 3 over 2. K is 4ac minus b squared over 4a. So this would be 4 times a, which is 4, times c, which is 13, um, minus 12 square over 4 times 4. So this becomes 16 times 13 minus 144 over 16. 16 is common, we have 16, and inside we'd have 13 minus 9 all over 16. 16 cancel. This comes out to be what? 4? Is it 4? Yes, it's 4. Just running back the calculation through my head. Yeah, yeah, man, it's correct. 16 times 9. 4, 5. Yeah, man, it's correct. 144. So, my minimum turning point is minus hk, which is um, 3 over 2. And again, this is from completing the square, 4. So that gives me my minimum turning point. But remember, in the very definition of the function, we're told that x must be greater than or equal to 3 over 2. All right, I need at least one more point to plot this graph. Um, I can easily show that when x is 2, I think y is 5. When x is 2, y is 5, I can easily show that. So if I wanted to, I have y is equal to 4x squared. Um, it's what, minus 12x plus 13. Now, when x is equal to 2, y, I just need another extra point to sort of like, this is 4 times 2 squared minus 12 times 2 plus 13. 4, 4 is 16. 16 plus 13 is 29. 29 minus 24 is 5. So 2, 5 is 1 point on the graph of the function. So let's do a quick sketch. The first point is the first point is 2, 4. Let's ensure that we didn't make an error. 4 times a, which is 4. Fine. 4 times a. Fine. All right. Looks okay to me. So my points are 1.5, 4, which is here, 2, 5, which is here, so my graph would probably look something like this. All right. I'm going to reflect this in the line y is equal to x, because that's how you obtain the graph that will reflect in the line y is equal to x. Remember, the line y is equal to x is a straight line that passes through all points in the graph where x and y have the same value. Y is equal to x. So 1.5, 4 becomes 4, 1.5, which is here. 2, 5 becomes 5, 2, which is here. All right. And then, so I'm ready to draw a sketch of the image. So if this is the function, y is equal to f of x, this would be the image, y is equal to f inverse of x. All right. So let's see if that was all. We're asked to what? Sketch what? The graph of the function and to sketch its image. And to sketch its image, which we did. All right. So this is the end of function 6.